Production support for Hot and Cold is brought to you by American Solar Technics, manufacturers of components for wood burning and solar heating systems. Hey, I'm Tom Gocze. This week on Hot and Cold, boy, we got a great project. We have a heat pump water heater we're going to install in our shop, the place where we do all our TV shows. We're going to make hot water, we're going to dehumidify, and we're going to air condition. And today is 90 degrees out. What better day to hook up the heat pump water heater than a day when it's humid in here and it's 90 degrees. We will explain everything you need to know about this right here, right now. Well, this is a Geyser heat pump water heater. It's a second generation heat pump water heater manufactured here in Maine by a Nyle Corporation. It's marketed by a company called North Road Technologies, and this is called the Geyser water heater. And if you can look it up online at geyserwaterheater.com. It runs on 110 volts. Very simple device. You plug it into the wall. It's a little dusty because I've had it sitting in the shop here and we've been making a mess. And we're doing something a little different. Normally this would sit in the basement. You sit it on the floor, you could put it up on blocks. We're having it up elevated a little bit from the floor because we wanted to do some air conditioning here in the shop. So by having it up a little bit higher, it's going to, cool air is going to drop down to the floor level. Rather than have it down low and chill at the floor level, we'll have it up a little bit higher. Maybe we'll get a little bit better air conditioning. It's not going to do an incredible amount of air conditioning in a shop this big. It's a very big place we have here. But this is a 6,000 BTU an hour device, and that's reasonable. So we will get some benefit from operating it. And we'll tie it in over here with our electric water heater. Let me hide the rags that I left from soldering. And it's made to interface with a regular electric water heater. Very simple hookup. It comes with hoses that tie from the unit. They screw onto the unit here. There's two connections for these hose connectors. One for cold water in, one for hot water out. We're going to plumb it a little differently. We're not going to use the hose connections because we're a little bit further away physically from the water heater than you would normally be in a residential application. So we've got it on this little shelf I built that is ruggedly tied in, hopefully, to the studs, and is quite solid. And we're going to go and use a connector. Let me take the other one down because we're a bit playing with the first one. These are adapters that allow me to go with a hose connection on this end. It's just a brass connector. You can get them anywhere. And it's a half-inch male connector on the other side. And then we have a half-inch male adapter to PEX tubing. And we'll just put those together. And we're going to screw those on. They have a gasket inside, just like a hose would. And these will hook up to these hose connections, and then we'll plumb it with PEX. There's really not a lot of hookup here. Took this up. In our case, we just tightened this down with an open-end wrench. And it's very simple. We do the two connections. I'm not going to do this other one yet because I think I'm going to have to crimp that. Well, let's put it on. Let's see what kind of mischief we're going to. Might have to. I can just pull the unit away from the wall. The crimp tool might not fit real well, but and we'll just tighten this one up too. And then we'll get some PEX tubing. This literally is a very quick installation. You can do this with copper too. I just like working with PEX because I don't have to solder stuff. It's quicker. It's more tolerant of bending. This is a plastic drain at the bottom of the water heater. I'm not going to take it out all the way yet because We need to be prepared. And the normal way the geyser hooks into the water heater is there's two of these T's at the base. These are bronze T's, or brass T's, excuse me. And we're going to go with Teflon tape that came with it, but I also like to put pipe dope on there as well. That's because a little bit of redundancy goes a long way. Now this is an old nylon plastic fitting. This water heater probably has been here a while, and it's probably not the best water heater in the world and probably should be replaced. But we're going to leave it. The test now is to see how long we can make it last for. This is a nipple that connects in where the valve goes, the shutoff valve goes. And on this nipple is a sensor. There's a thermistor here. You see there's two sensor wires. We've got to hook that up later. But we're going to pre-plumb some of this just by putting these together a little bit. And we've already drained the water heater once to get all the sediment out. So we don't have to worry about that. Regularly you would have to drain the water heater for any sediment. That's already done. We have a stub here we're going to put in as well. As I said, we're doing this a little bit differently. It's actually similar. There's a couple different ways to hook this up. This is the cold water that comes off the bottom of the unit, the bottom of the water heater that feeds into the cold inlet for the heat pump. And we're just kind of putting these in together roughly. I have a little stub of tubing here somewhere. Here it is. And I need 2 crimp rings, and you'll see why in just a moment, because this will be spewing on me, probably. Because that's good TV. We have a shutoff valve. So we're going to put the crimp rings on here to be ready. And we're now going to take the valve out and see if we spill water. This is a workshop, so it doesn't matter if we get some water on the floor. Does it? Yep. Let's get these pliers. There we go. I do not like these plastic valves. As much as I like working with plastic, I don't like plastic valves because they have the ability to crack and do things we don't want to have them do. But we're going to take care of that because we're going to put a brass valve in its place. Maybe I can get this with the open end now. There we go. Of course, the electric element is off. Here we go. Move those back for now. That's going to be a lot of water coming out. You think we can do this? Sure we can. All done. We do have to put the shutoff on. That's going to make it too high. So we're just going to crank this now. Is this good TV? I think so. The cameraman thinks it's funny. And we're just about there. Let's tighten. We do not want to over tighten this. There we go. All right, so that's, should we go around one more time? Sure. We'll put our crimp connector on. That makes it taller. Put our valve on. Hey, it's almost not leaking now. And we're going to put that with the shutoff valve that way. And, boys and girls, the only pressure that we have pushing out here is the height of the water inside the tank. Okay? So it's, you can never do this with city water pressure. Okay. That basically is done. We just want to turn this around a little bit so the faucet, the shutoff valve is facing up. Let me do it this way. So we got rid of this. We got this. We now have our inlet for the cold water to go from the water heater to the to the heat pump. Up at the top here, I've already taken the liberty of cutting in on the cold water inlet to the tank a T with another shutoff. Now there's no pressure on yet, so I can open and close that one. So now we can put the water pressure back on, and we can continue with the rest of the hookup, this is pretty much the lion's share of it. Okay, so we're running the PEX tubing into the wall cavity here, and I should be able to grab the tubing. Oh, here it is. It's already down here. Okay, and we're just feeding it through. And on this end, we'll take a little stub. 1, 2, I need 3 crimp rings. Again, very simple hookup. Put everything up here. We're going to come off of this fitting with a stub of tubing that's about, I don't know, 2 inches. Put that down there. So we got a stub here. We've got a crimp elbow. And again, that just inserts the PEX tubing in. Get another crimp ring. We're going to put it on here, like so. And then we'll hook up to our PEX tubing. Do we want to go like that, or do we want to go more? I should put the crimp ring on before I get too carried away. There we go. Of course, the beauty of PEX is we can do all these wonderful, weird compound curves. And we'll crimp the connections. 1. Oh. Make sure that's on where I want it to be. 2. 3. Okay, so that's the cold water that feeds the unit from down here, where we hooked up a little bit earlier. And I think what we'll do is just make this elegant sweeping curve, like so. Get it out of the way a little bit. We'll snip it here. We could do this with 90-degree elbows, but where's the fun in that when you have PEX tubing? Why don't you come around over there, Miss Camera Person? Here we go. We just insert that right on. And we'll snap that one with the crimp tool. We're ready to go. Now we've taken the luxury of pre-plumbing this, and we have a nipple here that comes with the unit. It has a thermistor, it's a sensor, that hooks up to the sensor lead over here on the unit. We're going to have to extend that a little bit. It's just 2 wires. 2 wires here, connected to 2 wires over here, and we're just going to tie in a little piece of wire to tie these 2 together because it's a little bit longer. And this tells this is the cold water temperature, and this tells the unit when to turn on and off. When the water is coming down out of here at the bottom of the tank warm enough, shuts the unit off. There's another lead here which controls the lower electric heating element. We're not going to hook that up because we're probably just going to disable we just shut off the electric to the unit because this will run enough that we don't have enough usage on this that we need to use any electricity other than what the heat pump gives us. So all I've got to do now is hook up the hot water line, and we can make hot water. Oh, this is simple. That's what I like about it. It's simple. I'm a simple guy. This is a simple project. You could do it. You don't have to be a plumber. If you know a little bit about doing things like this, hooking up tees with threaded fittings, you can do this. So let's get the other fitting in there and we'll be good to go. Okay, so the last connection is just here. We did the same thing up at the top again with the elbow and tying in, and we snip this here, and then we just can turn the water and we'll be good to go. But first we need to get some wire and hook up our sensor. We need to cap this off, and then we're basically done. This is a very quick installation. Okay, so we got everything ready to go with one exception. We have the hose, the clear vinyl hose, which is for condensate, because this thing is running as a dehumidifier. So we have to have this go somewhere. We're going to set this into a 1-gallon container where I will collect the water, it just got wet, which is distilled water to use in batteries for electric cars and other sundry items. Pretty simple. Now everything's hooked up. We just turn the switch on, and that's it. We are now in the 21st century. We have air conditioning, we have dehumidification, and we have hot water, and some of that stuff is free. And most of it is all of it is less expensive than normal. And what I mean by that is, when we run that electric water heater, we're using straight electric energy to make heat. It's 100% efficient. All the electric energy goes in that tank and makes us hot water. The problem is electricity is expensive. Presently, it's about twice the price of oil. When we turn this baby on, and boy, that's hot. That's good stuff. That's good TV right there. And then you see how hot that is? We are making hot water to go in that tank for at least 1/2, if not 1/3 or even less, the cost of running that. You follow that? We are cutting the cost of operation to less than 1/3 of what it normally is. That's good stuff. And then we get distilled water for free. So if you're into ironing or you're into electric vehicles, we have distilled water. We have dehumidification, which is extremely valuable on a day when it's 90 degrees outside and it's sticky and it feels like it's Texas. We have air conditioning, which is a benefit. So what we need to do is use more hot water so we can air condition more. That makes sense, doesn't it? But when you factor all that in, this is way ahead of the alternatives. And it really gets way ahead if you're running a dehumidifier, which is what you might be normally running this time of year in a basement or something. If this is in the basement, you're going to dehumidify the basement, nothing's going to get moldy. So that is a really nice attribute of this setup. Now, this is not inexpensive. This setup, these systems cost around $1,400 uninstalled. But there's a tax credit. There's a 30% tax credit that you get for the system, and that would include installation too. So you can take 30% off of whatever it costs you if you have somebody install it. And let's say for the sake of discussion, you spend $50 a month for hot water. That's not unheard of. If you can have that number, you got $25 a month that you're saving, times 12 months in a year, that's $180 a year that you're saving in electricity. You got dehumidification and/or air conditioning as a byproduct. That might be represent another $25 a month. So all of a sudden, there's some synergy that takes place here. What excites me even more than that, though, is the fact that I can set this up and do some very interesting, fun things with it. This is a water heater. We bought it as a water heater. We present it to you as a water heater. But to me, it's also a tool for moving heat from point A to point B. So if you have maybe a room, a sun space, say, that is always hot when the sun is out, this could use that as a heat source to shun energy. This could cool it down in the summertime. If you have a wood stove that tends to overheat the house, this could be a means for running the wood, taking the heat out of the wood stove or away from the wood stove when it gets the building too warm, and shunt it into the water heater to store it for later use. Additionally, if you're doing a solar heating system, you always have to have some kind of backup heat. We can use this for backup heat. Now, in our installation here, we're in a shop setting. We have a 40-gallon electric water heater. I have shut off the 40-gallon electric water heater, and we're not running out of hot water because this is keeping up very nicely. I can't tell you that I feel any appreciable chilling effect in here. I want to, because it's 90 degrees. I can feel a little bit. But it'll be interesting to see as we get into the heating season if this is going to be a problem or not in this space. It may not be. We might wind up leaving it on year-round. We splash a lot of water around here with these tanks. These are test tanks that we use. We test liners in them. So we're always splashing water around because I'm always doing some kind of experiment on something. So this gets the water out of the space and keeps the floors drier quicker. As a matter of fact, I've been spilling water all day today, and everything is pretty much drying up. I've had this running intermittently. So, you know, it all kind of fits together. This is a wonderful tool. When you factor in the fact that we have this wonderful tool that's doing water heating and air conditioning and dehumidification for us, and then you get the trump card that it's made here in Maine at a competitive price, and there's tax credits available, it all is very positive. So there it is, the Geyser heat pump water heater. And one other thing before we go, I know we're running out of time. They make these, there's some companies that are making these that are integrated into the tank. So you get the tank with the heat pump on top, and it's nice and it's compact. The problem is this: when the water heater tank fails, and they do fail, what do you do with the heat pump? I like the idea of having this as a separate component that I can do any number of things with. I can hook it up to that tank, I can hook it up to this tank, I can take it out, take it with me if I move, I can just shut off the valves, cut the pipes, and drag it to my next house if I want to. That's all good stuff. So this is much more utilitarian, and I think was designed that way because it was made here in Maine. Anyway, take a look, geyserwaterheater.com. You'll see at the end of the show as well, and we'll be reveling in this thing for a while. Production support for Hot and Cold is brought to you by American Solar Technics, manufacturers of components for wood burning and solar heating systems.